In previous lecture, we started our discussion of electric circuits ending on Ohm's law. We're going to continue that, and in this case, we're going to discuss the various types of components that might be inserted into a very simple Arduino project, for example, and look at two very simple circuits and try to understand how it is that they work. All right, so remember we have Ohm's law, which is just that the voltage in a circuit equals the current times the resistance within that particular portion of the circuit. Remember, I is the current in amps, R is resistance in ohms, and V is the voltage in volts. And remember that volts essentially is the change in potential energy between the poles of our battery. All right, so these are the components we're going to be looking at: resistor, diode, light emitting diode, RGB, LED, again, light emitting diode, potentiometer. We'll talk about those each in turn. Resistor, we already looked at this in our last lecture. They do carry these colors that indicate the ohmage or the resistance and the number of ohms. And I believe they're also rated by the current that you'd want to put through them. This is the schematic that we use, or the schematic symbol that we use in our circuit drawings. All right, diodes. Diodes is something new. Diodes only allow current to flow in one direction. And they're shown using this symbol here on the right, where the direction, the arrow is essentially the direction of flow that is allowed. Wire your diode backwards in your circuit, and you're going to get no current, and your project is not going to work. LED diode, or light emitting diodes, or LEDs. Essentially, it is a diode as before, but in this case, it also emits a small light, and they're useful in many settings. And the symbol is just the same as a diode, but with the arrows indicating essentially that you're getting light from the system. And when you have a LED, be aware that you'll find that the leads are different lengths. The longer lead essentially is the positive lead. And don't, again, wire them backwards, no flow of power, because it only allows power to flow in one direction. All right, this is the RGB LED. So in other words, red, green, blue LED light emitting diode. It can flash either red, green, or blue, or some combination of them. This is essentially what we have in our LED screens on our computers. And you just generate the color you want by sending current through 1 for red, 3 for green, 4 for blue, and the power comes back out the other end through our common cathode. That's the longer of the leads, lead number 2. Potentiometer essentially is a variable resistor. In other words, the resistor, which the amount of resistance that's applied depends on how you dial this little, or where you turn this little dial, what setting you set it at. So it can be like wide open, almost no resistance, or it can be increased up to some maximum amount of resistance. All right, so this is kind of the inside of our potentiometer. The current is flowing in through the green, out through the black. The blue is our ground. And the way it works is the longer, you can see when we turn the dial on the potentiometer, it essentially moves this black line essentially around. So here, in this case, it's basically at like 3 o'clock, and over here, it's on the right side, it's essentially at 9 o'clock. And when it's in this sort of 3 o'clock position, this yellow portion is short, whereas you see in the 9 o'clock position, the yellow is longer. So there's more resistance applied on the right-hand side when we've turned the potentiometer over here than there is in this instance on the left side. So that end result is that we're going to have less resistance, more current. On the right-hand side, we're going to have more resistance, less current. Breadboard. So a breadboard is a way of creating circuitry. So you can plug in the leads of your LEDs, of your diodes, of your resistors, potentiometers into these small holes, and then also power the board by bringing power from some battery source or other source of power into these. Typically that's done into these vertical strips on the left or on the right. So it's what we've done on the right hand side here is we've pulled off the backing so we can actually see in the side of the breadboard. So what you can see is here in this first row, this black is essentially showing you that these are all connected. So connecting a resistor from say F1 here to either E1 to D1 to C1, it's all the same because these are essentially like one point, but you're able to through the breadboard to use different holes to connect them to the same point. These horizontal strips are divided down the center, so we have the ones on the left represented by A through E, and then the ones on the right represented by F through J. So you can see again it's rows and columns, and each of the rows are distinct and separate. And then on the left and the right there are these vertical strips. You can see here on the backing, when the backing removed, the vertical strips are all connected. So we can connect from, say, put a lead from across from A1 to here, and then we can bring power in, say, through this bottom hole, and that'll essentially bring power to the plus up here, to that hole, and then into this, say, resistor that we brought in from A1. And I'll show you examples at this in a minute. They're called breadboards because years ago, hobbyists, electrical engineers, in some instances would actually take a wood breadboard and knock nails into it and then start wrapping wires and leads around the nails. And so from that sort of primitive way of working, we've developed this breadboard, which is much easier for us. All right, so here's a very simple circuit. On the left here, this is referred to as our Arduino board. In this case, in the center is the computer chip. It says here red board, but in fact, they're known generically as Arduino boards. The red board is one particular manufacturer's name for it. All right, the power goes out through pin 13. So each of these are essentially pins you can put wires into. I know from looking at the source code for the circuit that power comes out through 13. It's going to come up here through the screen wire, and then you see it's going here into E2. And then this LED essentially is what this is plus minus. That, remember, light emitting diode. That one is into D1, so that power goes from DE2 to D2 because those are connected. And then it's connected over here on the other side at B3. And then we have a resistor coming into A3, so we can see that the power goes through the diode to the resistor, hops across this little space, and then gets into our negative power strip area at this pin here. And then remembering that they're all connected vertically, the power comes down here to this black wire and returns to our Arduino board at the ground, GND. The Arduino board is powered itself through a wire, a USB cable that's plugged into a computer. So this is simply the very simple circuit that we dealt with the first time when we were first understanding Ohm's law. In the case, this is that resistor that's reducing the current sufficiently so that we don't blow out our LED. Here's another case of a RGB LED. In this case, the current or the power is coming from pins 9, 10, and 11, coming across through our breadboard, being fed through the resistor over the gap to this row, into this LED lead, into the LED, out through the common cathode to the black wire that returns to the ground. So that's a very simple circuit. That's how you need to think about these circuits and trying to understand how they work as you work through your Arduino projects.